So this is C3 differentiation, looking at the quotient rule. The quotient rule is defined as follows. So if we're given a function of the form y equals some function u of x divided by some function v of x, then dy by dx is defined as v times du by dx minus u times dv by dx all over v squared. Unlike the product rule, the order of these top two terms is important because, of course, subtraction, the order is important. You can write this in function notation as vx times u dashed of x equals ux times v dashed of x all over vx squared. So let's have a look at example 1. In example 1, we're asked to differentiate y equals x to the power of 5 over 6x plus 1. We have a function of x u on the top, and we have a function of x and v on the bottom, so numerator and denominator. So let's differentiate this then. Start by defining u. U is x to the power of 5, and v is 6x plus 1. Differentiate the two functions independently. So du by dx is 5x to the power of 4, and dv by dx equals 6. Now, the quotient rule, dy by dx, is v du by dx minus u dv by dx all over v squared. And the way I remember the order is VDU, Visual Display Unit. I can't think of any kind of acronyms which would match up to this second one. So it's Visual Display Unit first. So now substitute these values in. It's worth noting that VDU, if we link them, they cross like this. So we're going to link these two terms. So writing this out, just plan it carefully in mind. Think about it. How would this multiply out? And this would multiply out. I've got a bracket here. So I'm going to use this term here as a coefficient of that bracket. So I'm going to have 5x to the power of 4 times 6x plus 1 minus. And then if we join up the other way, diagonally, this gives us our other term. And so instead of writing x to the power of 5 times 6, we're going to do 6x to the power of 5. And this is all over v squared, so 6x plus 1 squared. So the majority of the marks are given up until this point. There are then marks for simplifying expressions. So what I need to do here is I'm just going to factorize terms here. We've got a common factor of x to the power of 4, so I'm going to take x to the power of 4 outside the bracket. That leaves me inside the bracket 5 times 6x plus 1 minus 6x. Okay, so this is all over 6x plus 1 squared. Now inside here, you should be able to see that I can expand and simplify this. So dy by dx, just tidying up a little bit more, x to the power of 4. We get 30x plus 5 minus 6x. All over 6x plus 1 squared. And then finally, just tidying up again, simplifying those terms. And you may be able to streamline this ever so slightly. I'm just showing the full working at this point in time. So I get 24x plus 5 all over 6x plus 1 squared. And that is how to use the quotient rule. Very, very similar to the product rule. Identify u and v, differentiate u and v, substitute it into the rule, and then do any simplification that's needed to get a nice, neat term. Okay then. Well, let's have a look at a second example. It's worth noting in the second example, here again we can see that we've got two functions, u and v. And it's just worth noting that just like the product rule, we may have to use the chain rule in conjunction with the quotient rule. So here we have a function within a function. So it's a composite function. I've got this function 2x plus 1 is inside the function of cubing. So just make sure you use the chain rule and keep an eye out for using the chain rule. So we know that u is 2x plus 1 cubed and v equals x to the power of 6. Differentiating u using the chain rule, I get du by dx equals, differentiate the outside function, I get 3 times 2x plus 1, and drop that power squared, so the inside stays the same, and I'm going to multiply it by the derivative of the inside, so I'm just going to multiply it by 2. So du by dx equals 6 lots of 2x plus 1 squared. V, differentiating v, dv by dx equals 6x to the power 5. Now again, the quotient rule doesn't change, so dy by dx, visual display unit, v du by dx, minus u dv by dx, all over v squared. So substitute the values in, dy by dx equals, again, still the cross multiply, make sure we cross multiply the simplified terms. Let's get the red pen so we can see that. So we're going to cross multiply these. So again, what I want to do is I want to put this, I want to think about how would this tidy up. So I'm going to do 6 times x to the power 6 times that bracket. So 6x, 6, 2x plus 1 squared minus, cross multiplying the other way, we get 6x to the power 5 times 2x plus 1 cubed. So we're going to put the 6x to the power 5 as the coefficient, 6x to the power 5, 2x plus 1 cubed. And this is all over v, which is x to the power 6 squared. So now factorising, you'll notice that I've got a common factor of 6x to the power 5 and a common factor of 2x plus 1 squared. So again, most of the marks given up to this point, and then there's an extra mark or two for simplifying. So the common factors were 6x to the power 5 and 2x plus 1 squared. Inside the bracket from this term, if I divide this by 6x to the power of 5, I just get left with x. And if I divide this by 2x plus 1 squared, I get left with 1, so we just get the term x at the front here. Then if I divide 6x to the power 5 by 6x to the power 5, we get 1. Divide 2x plus 1 cubed by 2x plus 1 squared, and I get left with 2x plus 1. So this is all over then x. X to the power 6 squared is x to the power 12. Now notice here I can cancel x terms. So start to simplify. So I'm going to do two things. I'm going to cancel x terms top and bottom, and I'm going to simplify this bracket in here. So I get 6 2x plus 1 squared. Inside the bracket, I'm going to get minus x minus 1, because I'm going to do x minus 2x is minus x, and then minus 1. All over, I've cancelled x to the power of 5, I've divided through x to the power of 5 top and bottom, so I get left with x to the power of 7 on the denominator. Finally, just tidy up, because what I can do is I can take a common factor of minus 1 just to tidy that bracket up a little bit more. So I get minus 6 times 2x plus 1 squared times x plus 1 all over x to the power of 7. And that is all we need to do. Okay, so in summary, just very quickly, just remember that the quotient rule is extremely similar to the product rule. Okay, identify your u and v, differentiate them, substitute them into the formula. That is the bulk of the marks within the exam. And then finally, there are additional marks because in some cases it may be a requirement to simplify. So in every question in your exercises, etc., practice factorising and simplifying. Okay, I hope that all made sense and you was able to follow it.